Now I'm just going to work through what happens with these data points. Okay, so we have y equals ax to the p with data points 1, 3, and 3, 6. But that gives you two equations. And here's your x, here's your y. So you get 3 equals ax to the, or a times 1 to the p. And you get 6 equals a times 2 to the p. 3. Now you divide this equation by this one. So let's call these 1 and 2. And we're going to do 2 divided by 1. Now I'm going to switch sides. We're going to get a times 3 to the p over a times 1 to the p. And that equals 6 over 3. We divide this out and we solve it. We can rearrange this as a over a, and that's what I want to see you do, because everybody wanted to tell me that you divide the p by the p and you leave the a in there last time. Okay? Now there's some exercises, incidentally, that you're going to need to do for homework where you write out these things and understand why the laws of exponents are what they are. Because you're not remembering them and you're not applying them. Okay? And this is almost everybody. Okay? I don't think anybody is reliably going to use the laws of exponents correctly unless you learn why they're true. You memorized them long enough to pass an SOL, long enough to pass tests in Algebra 1 and Algebra 2 or in RMTEs, but you don't know them because you don't check. Okay? You don't know how to check them. And it's something that needs to be taught, but it's pretty easy to do. So I've got some exercises where you do that. Anyhow, digression. Okay? But one big thing though, your algebra needs to get better. Okay? You can't be making the kind of mistakes that I've seen almost everybody make. Okay? Bad cancellation. I don't allow cancellation. Okay? And a bunch of other stuff. Okay, so we do the algebra like this. A over A multiplied by 3 to the p over 1 to the p equals 6 over 3. Well, a divided by a is 1, and 3 to the p over 1 to the p is 3 over 1 to the p, and you need to understand why. Again, there's an exercise that'll make it clear why. Okay? And that exercise, incidentally, is not even a pre-calculus exercise. It's not even part of this course. It's something you need to know to do this course. Okay, so anyhow, you get this. So that's just 3 to the p equals 6/3. So that p equals log to the base 3 of 6/3, which is log to the base 3 of 2, which is log of 2 divided by log of 3. That equals what it equals. Okay? I'm thinking that's around point. I don't want to try to go any further than just the first decimal point. I think that's probably around 0.6. Because 3 to the 1/2 is 1.732. You need a little higher power. I think it'd be 0.6, might possibly be 0.7. Okay, so we have that. And then we plug this back in to one of our original equations. Okay, so this tells us P is approximately 0.6. Let's plug that back into the first equation, which is then going to give us I don't want to plug that into the first equation because I got that 1 there. It's kind of a bad choice of a number on my part, but I'm going to plug it in here just to show you how it generally works. So we get 6 equals A multiplied by 3 to the 0.6, approximately. With your calculator, get 3 significant figures, get it right, okay? But the calculator's easy. It's not arithmetic you can do in your head. So A equals 6 divided by 3 to the 0.6 power. Which is 6 divided by 2, which is 3. So now, and this is a step, everybody gets hung up in the algebra and you're concentrating on the algebra. Now, I've seen a lot of people not finishing the problem. Now that's okay, but start finishing the problem. It's easy to finish it. You finish it by the model, by writing the model. So it's something like 3x to the 0.6. Okay? Then you check your points. If y equals 3, x equals 1, we get this, and that checks. Okay? And if y is 6 and x equals 1, we get 6 equals x isn't equal to 1, x is equal to 3. It checks, that's okay, there's our model. Now we want to talk about graphing the function, but we're not going to do that just yet. Let's get the process of modeling down. We'll talk about how to graph these next time. Okay. Now, y equals ab to the x with the same points, 1, 3, and 3, 6, gives us equals a times b to the 1, and 6 equals a times b to the 3rd. So if this is equation 1, this is equation 2, we divide equation 2 by equation 1. It doesn't matter whether you divide 2 by 1 or divide 1 by 2, but I usually take the one with the higher numbers and put it in the numerator. It's a little less error prone. We get a times b to the third over a times b to the 1 equals 6 over 3. So that a over a times b to the third over b to the 1 equals 2. So that 1 times b squared equals 2. So that b equals the square root of 2. Now, the solution to b squared equals 2 is b equals plus or minus the square root of 2. But the base of an exponential function has to be positive, can't be negative. Okay? So what we do is we discard negative square root of 2, can't be the base. Of an exponential function. Well, we take that and we plug it into either equation. And let's plug it into this one just because it's a little more interesting. Okay, we plug that in, we get 6 equals a times the square root of 2 raised to the third. Okay, well, square root of 2 raised to the third is about 2.8. Approximately 2.848 if you want it, but 2.8, and that's just something everybody born before the age of calculators knew better than they knew their own name. Okay? Just a number, square root of 2, that pops up so often that even if you don't want to memorize it, you memorize it and you can't ever forget it. Okay. Yeah, when you get my age, maybe you could forget it. Okay, but I'm saying 2.14, that'd be 5.64 over 2.8. Yeah, I'm saying 2.14, but then that doesn't have more than 2 significant figures, so that number would be ridiculous. Okay, so we have a equals this, we have b equals this, so the model approximately 2.1 times square root of 2 to the x. Okay? Now, on the picture over here, the power function that you get going to be something like this. I haven't drawn the shape very well. And the exponential function, something like this. Looks like it's decreasing there a little bit. Okay? So what I just drew is, for the 2 points, there's an exponential function. Goes through the 2 points, and there's a power function. The chalk's not going where I want it to through the 2 points. Again, we'll talk about how to graph them, but you see that this looks something like your square root function, the inverse of your x squared function. Yeah. So this is like your, again, it's not very well drawn, y equals 3x to the 0.6. Y equals 2.1 times the square root of 2 to the x. There's a linear function, goes through the same 2 points, and we want to look at how that works out. And of course, your linear function will pass through these points, it'll be a straight line kind of in between these. It'll intercept the y-axis somewhere, and we're going to find out where. So, wrong form. AX plus BY equals 1. I'm going to use this form instead of the y equals mx plus b. Now remember, you can do a fundamental triangle for these points to get a slope. Then you can put a point xy out here and do a slope of one of these points to that triangle and set the expressions for the slopes equal. You're going to get the equation. You need to know how to do that because it tells you more about what the equation really means. But this tells you a lot too. So what we're going to have is, again, the points are 1, 3, and 3, 6. So we're going to get a times 1 plus b times 3 equals 1. And we're going to get a times 3 plus b times 6 equals 1. So we write that more like a plus 3b equals 1, and 3a plus 6b equals 1. This will be equation 1, this will be equation 2. Various things we could do with this equation. We're going to do what we usually do. We could either multiply the first one by -2 and leave the second one the way it is, and then your b's would go away. Or we could multiply the first one by -3, leave the second one the way it is, and your a's would go away. Do it either way. Okay. Well, since we're kind of used to picking on b, I'm going to pick on a this time. Okay? We're going to do -3 times the first equation, giving us -3a minus 9b equals -3. And the second equation, 3a plus 6b equals 1. We add the equations, and we get -3b equals -2, so that b is -2/3. We bring that up here, plug it in, and we'll just plug it into the first equation, which will come back here as a plus -2/3 times 3 equals 1. Well, that's going to then be a minus 2 equals 1. A equals 2. So the model is 2x minus 2/3 y, the board's a little rough, equals 1. Okay? Well, I am going to graph this. If x equals 0, you get 2 times 0 minus 2/3 y equals 1. So y equals -3/2. That is the y-intercept is 0, -3/2. And then if y equals 0, you get x equals 1/2. So the x-intercept is 1/2, 0. So the graph would look like this. If this is -1 and this is 1, here's your x-intercept, here's your y-intercept. X-intercept is 1/2, 0. And the y-intercept is 0, -2/3. If you did the fundamental triangle for this, you would find that the slope is 3/2. Okay, so if we do this fundamental triangle, (0, -2/3) here, 1/2, 0 here. You see your rise is 2/3 if you go in this direction, and your run is 1/2. So your slope is 2/3 over 1/2. Well, 2/3 divided by 1/2 is 2/3. Times 2 over 1, it looks like I've got a mistake. So that's giving me 4/3. Let me look at my equation. No, that's right. Okay? And that should agree with the slope between the 2 points wherever I put the graph. It's 1,3 to 3,6. Goes up 3 and down 2. There could be a discrepancy there. Probably have you work these out yourself for homework. Okay? Remember the points right. You can have the fun of figuring out what I did wrong. Where in the world did I put it? That's behind this one. Okay. Yeah, that's 2, that's 3. So line should have a slope of 3/2, which is kind of what I said before. So something's wrong in this solution. 3/4. That's it. Yeah, sure. Yeah, I'm not going to find it. There's a mistake here somewhere. Okay? So, yeah.
A equal 3.
I'm sorry, Anthony.
Wouldn't A equal 3?
Wouldn't A what?
Equal 3.
Ah. I wrote a sloppy 3. It looks like a 2. Actually, I wrote 2. Okay? So, error here, and that error reconciles it. Okay? So I pretended to see an error here, so you would see how in checking this thing out with the original data, it doesn't work. I get the wrong slope here. I didn't really pretend, but let's go ahead and make something out of my error. Okay? So I wanted to check and make sure I had the right slope, because the slope here has to match the slope of the original. And the slope between the original 2 points is clearly 3/2. Points are 1, 3, and 3, 6. Okay, run is 2, rise is 3. And that's not what I got here. Okay? So, slope between 1, 3 and 3, 6 is 3/2, not 4/3. Slope's got to agree because this is a straight line. Okay? Okay. Now you see, if we do a little better picture, we're starting from like -2/3. This would be 1, and this would be 1. So 1, 3 would be about here, and 3, 6 would be about here. That doesn't look right at all. So my scale's screwed up. Let's fix it. Okay. So if this is -1, 1, and let's say this is 1 here. Here's 1/2, so the graph has to go through these points. The point 2, the graph goes through those points. It doesn't go through the point 1, 3. Well, that's because I have a mistake here. Okay? So there's no way I can make this graph agree with the original. So, get rid of this stuff. And estimate where this should be. Here's 1, 2, 3. Here's 1, 2, 3, 4, 5, say 6. So 3, 6 is about here. 1, 3 is about here. And it looks like with those points, the graph goes through something like 3/2, not a negative number. A should be 3, Okay, well, that's giving me a y-intercept. Still getting a negative. Mess this up too. That's a negative, that's a negative. I didn't see it. That's 2/3. Okay? It's another error. Okay, now it's corrected. I had a negative here. Okay, so it's going to work out, and it might well be 3/2. Okay, anyhow, we've got these points. We've got an exponential model, and the exponential model tells us what? Tells us that 2.1 times the square root of 2 to the x. Exponential model tells you go through 2.1, which should be about here, and that makes a certain amount of sense. You have an exponential function that comes up here and up here, starts taking off. And we have the power function. Don't have it written down, I've got it somewhere. Yeah, 3 times x to the 0.6. Well, that has to go through the origin, has to go through here and here. So, right there are the picture, that's a picture of the 3 functions that pass through these points. This is a power. This is exponential. And this is linear.